So before we actually start taking our notes today, what I want is to see what you guys remember about writing equations, linear equations. What are some things that you guys recall from that chapter, that unit that we studied? Linear equations. What's something, Pete? You have to have a variable y. That has to be part of it. So we have a particular form. And by the way, what's this form called? It's called slope-intercept form. And it is actually not the only way to write a linear equation, but that was the way we focused in on. Okay, what are some other things? Got to have an x value. So it's got to have two different variables that are in it. You don't have to have a... And what is the b value, by the way? It's called the y-intercept. And he can be absent. You don't... Well, you're going to have him, but it could be a 0. Let's put it that way. Could be 0. Because you could be passing through the origin. Okay. What else? There's something else from that formula that hasn't been mentioned yet. Cleo? Slope. Okay. Now, we talked about figuring out slope if you were given 2 points, and we had a formula. So what was the formula that allowed me to calculate slope if I was given 2 points? Faith?
Well, like, do you mean ordered pairs?
Pardon me? Yeah, if you had 2 ordered pairs, which are 2 points.
You would subtract the y's and the x's.
And the key is not just subtracting the y's and the x's. The y's have to be on top because it's that idea of rise is a y value and run is an x value. So we have a formula, slope equals the y subtracted and the x's subtracted. Now, just to pay attention to one thing for just a sec. The x and y value that are above and below have to be from the same ordered pair. So that's really important that when we're writing it. If we write it backwards, so we do y1 minus y2 over x2 minus y1, we're going to get the right number, but we're going to get the wrong sign, which is going to take our slope from going one direction to the absolute opposite. So it's like the worst thing we could possibly do. Okay, so that's what we're going to work on today. I'm going to give you 2 points, and your job is to come up with the equation. Okay, so let's go through that. So that's our objective today. Given 2 ordered pairs, write the equation of the line, of the line passing through the 2 points and we're going to focus on slope-intercept form again. Okay. Right. Okay, so given 2 ordered pairs, write the equation of the line passing, through the 2 points. Use slope-intercept form. Okay? So that means, if you notice up on the board, you guys are going to be doing homework out of the textbook today. And pretty much all this week, with the exception of an additional review worksheet today and another review worksheet on Friday. All right, so let's come up with 2 ordered pairs. Somebody give me 1 ordered pair. Faith.
7, 4.
And I need another ordered pair. Joy.
3, 2.
Okay. So I have this ordered pair. I need to write something that looks like this. So what am I going to start with? What am I going to do first? What's my number 1 job?
You do the rest.
Okay, I can only do rise over run if I have it graphed. And that's going to be, I would say, a very time-consuming thing, so I'm going to avoid graphing if I can. But I have an alternative we talked about that I could do to figure out what does rise over run actually tell us? Slope. So we want to figure out slope, okay? And so what can we use? Are you chewing gum too? Garbage can. So we're going to find slope, and what are we going to use to find slope? We already wrote it down. Nope, you can't do rise over run. The only way to do rise over run is if I graph it. What are you going to do? Look back at the top of your notes where we wrote down all the stuff that we know our linear equation needed. Sarah. We're going to use our formula. Our slope formula says slope equals the difference in the y's over the difference in the x's. So what I'm going to do is assign x sub 1, y sub 1 to the first ordered pair, and I'm going to assign x sub 2, y sub 2 to the second ordered pair. And it doesn't matter the order that we do this, but that way you can kind of track things a little bit better. So we have slope equals the first y minus the second y over the first x minus the second x. And we just do the math. So 4 take away 2 is 2. 7 take away 3 is 4. Now, I have to remember, as with all fraction answers, what do I need to do with that value? I'm going to simplify it. And what is 2/4 reduced down to? 1/2. Okay, so it can reduce by a factor of 2. Now, the other way of looking at how to put this together, we talked about. So you can take your ordered pair and you can rotate it 90 degrees to the left so the y value is on top and the x value is underneath it. So this is 4/7. Take this, rotate it 90 degrees to the left so the 2 is on top, 3 is on the bottom, 2 over 3. And you just have to remember that you're then going to connect up to make one big huge fraction, and you're going to subtract both in the numerator and in the denominator. So far, we're here. Y equals 1/2 x plus b. Now the x and y are going to stay and the equals are going to stay. Now we have the half that's going to stay. So our job is to figure out the b. So what's the second step we're going to do in order to figure out the b, the y-intercept value? We did this before. Johnny, remember? Okay, so we're going to substitute in one of the ordered pairs into this partial equation, the one that has the slope in it, and we're going to solve for b. So I'm going to do, write that here, we're going to substitute one ordered pair in for the x and y of the partial equation, and in this case it would be the y equals 1/2 x plus b, and solve for b. Or in other words, the y-intercept. So step 2, which ordered pair should we choose to plug in to that partial equation y equals 1/2 x plus b from this particular example to solve for b? So what I want to hear is what you would choose and why you would choose that particular ordered pair. What do you think, Jack?
3/2.
Why would you choose 3/2 and not 7/4?
Because it's the smallest.
And that's a good reason to pick. Is the smaller the numbers, the less likely we are to make careless mistakes. So I would agree that would be the pair I would choose. What if you had an ordered pair that had both positive values and one ordered pair that had at least one negative value? Okay, so I would tend to go with the positives, okay? That's also going to have an effect on who I choose to be my first ordered pair when I'm calculating slope. If I have an ordered pair with a minus in it, as a subtraction sign and negative sign, I'm going to put that in the front so not to confuse it with the subtraction sign between values. And so we'll do our next one, we'll have a negative in it. All right, I'm going to go to the next screen, and we're going to choose 3, 2 as our x and our y. So we've got our frame as y equals 1/2 x plus b. We've got our ordered pair is 3, 2. So remember the value, 3 is the x value. Let me put in my frame here. So we've got the 1/2 is there, and then we've got the plus b. So what we're going to do differently is what we put in. The 3 is going to go here next to the x, and the 2 is going to go here for the y. So my equation now is going to be 2 equals 1/2 times 3 is 3/2 plus b. Now I'm going to use that symmetric property to take what's on the right and put it on the left, take what's on the left and put it on the right. So we've got a bit of an issue. Joey's hands are all muddled up so he can't take notes. What's the problem we have right now? That it sometimes causes issues for some people. Corey? We have some fractions. So what have we talked about, Corey, that would help us get rid of the fractions to make this easier to solve?
Change the 2 into a fraction. Or multiply by 10.
10's not going to do it. I went multiply by 10. There's an easier way of handling this one. Riley, remember?
You times it by the reciprocal.
Not by a reciprocal, because then that's going to actually cause fractions. So I'm trying to avoid fractions. So what do we talk about that we could do to any equation to avoid having to calculate with fractions? Oh, this is so simple. Kenny?
Multiply the 3, 2 by 2, 3. So they cancel each other out. Then you could do the same for number 2.
But the problem is, if I multiply by 2 over 3, I have to multiply everything by 2 over 3. I've now created a fraction in front of the b, and I've created another fraction at the end. So again, I'm trying to avoid fractions altogether. Megan, you remember?
Multiply everything by the denominator.
Yeah. The easiest way is to multiply by the least common denominator. There's one denominator. It's a 2. So if I multiply everything by that 2, it's going to eliminate the denominator here, leaving me with 3 plus 2b equals 4. Now, some of you are confident enough that you can just deal with the fractions, but some people need some help, so that's why we're reviewing this. So now we just start doing opposite operations. So we subtract 3 from both sides, and we get 2b equals 1. And then we divide both sides by 2. And we get b equals 1/2. So now we have the 2 key ingredients to write our equation, and our final equation is y equals the slope of 1/2 times x plus 1/2. Well, that's interesting. We ended up with the same slope and y-intercept. That's just the way it works. Now, just to make sure you guys understand this, if I chose the other ordered pair, if I chose 7, 4, here's how my calculation would have worked. I would have had 2 equals 1/2. Sorry, change that again. 4 would have equaled 1/2 times the x value. That's weird looking. Times the x value 7 plus the b. That gives me 4 equals 7/2 plus b. Again, I'm going to multiply everything by 2. That gives me 8 equals 7 plus 2b. Subtract 7 from both sides. Use symmetric property. 2b equals 1. Divide by 2. And I get the same exact y-intercept. So again, it doesn't matter which ordered pair you choose to plug into your partial equation, where you've already figured out slope. You're going to get the same answer. All right, let's do another example. Let's grab some ordered pairs from here. Let's do 2, 3, and negative 2, negative 2. So those are our two ordered pairs. What's our job 1 to do? Can't put it into slope-intercept form. We need to know what the slope is. So we're going to use our formula. Now, this one, because I have an ordered pair that has negatives in it, I'm going to put that ordered pair in front. So I'm going to have negative 2 over negative 2. And then I'm going to take 3, y over x, over 2. I'm going to connect them and subtract. So what this does is it does not interfere with the sign of a value and the operation that I'm doing. And then I just keep doing the math. So negative 2 take away 3 is negative 5. Negative 2 take away 2 is negative 4. And what would the answer be? Yeah, we have double negative makes a positive. So right now, we're at this point in our equation, y equals 5/4 x plus b. All right, what would be probably the better choice for figuring out the y-intercept on this one?
2, 3.
The 2, 3, and why would we pick 2, 3?
Because it's not negative.
Yeah, because we're not contending with negatives is a good idea. So we're going to put the y and the x values here. So the y value is 3 equals 5/4. The x value is 2 plus b. If you notice, you've got 5 times 2 over 4, so 2 can go into itself once and into 4 twice. And that gives you 3 equals 5/2 plus b. So what could I multiply by to eliminate the fractions?
What did you switch it first?
6? Are you telling me 6, Riley? Even easier than that. What can I get rid of? What would I multiply by? I only have one denominator.
2.
Yeah, I'm going to multiply by that too. So eliminates the 2's. 3 times 2 is 6. Equals 5 plus 2b. Oh my goodness, interesting. Look what we ended up with. 2b equals 1. Divide by 2. We got another y-intercept of 1/2. Let me just say that doesn't always work. So again, all we're doing for our final answer is grabbing the slope, grabbing the y-intercept, and putting them in their appropriate spots. So we get y equals mx plus b. Okay? All right, I'm going to have one more. I want you guys to do this on your own. What if we have the ordered pairs of negative 3, 4 and 4, 7? And voila. I chose to put the ordered pair with the negative in the front. So then my y value over my x value minus my y value over my x value. It originally was negative 3 over negative 7, which since they're both negatives makes a positive, and I got the slope was 3/7. So at that point, my frame was y equals 3/7 x plus b. Then I chose 4/7 as my ordered pair because it didn't have any negatives. So in for y went the 7, in for x went the 4. So when I multiplied 3/7 times 4, I had 12/7. I didn't really want to contend with the fractions, so I multiplied by the denominator 7, everything in the equation by that. That gave me 12 plus 7b, I used the symmetric property, equals 49. Subtracted 12 from both sides, that gave me 7b equals 37, and then I divided by 7 on both sides to get b equals 37/7. So my y-intercept was a positive 37/7. So I get y equals 3/7 x plus 37/7. Now the whole reason why we are learning this is because drawing scatter plots is just the beginning. Your job afterwards is to then figure out what line would best represent the data, and using that line predict things from the future. That's called line of best fit, and that's what we're going to be talking about as of Wednesday. So in order to do the line of best fit, we got to figure out how to write its equation. So we'll be using this process with our scatter plots starting Wednesday. So that's for your homework on the algebra book 331, 13 through 25 odd.